This is section 2.6 in the beginning of our unit on graphing irrational functions. First, we just want to talk about different characteristics of a graph, how to identify it so that when we start to calculate them, you'll know what we're talking about. So the first one is a hole. Like these are actual literal holes in your graph. We'll talk about why they happen, but that is essentially saying there's no value here. The function happens up until that point, it skips this value and then continues on going. So holes, they are literally holes in your graph, and your card or your theorem card about how to do these, it says that you're going to factor and cancel first, and then your holes are found by anything that cancels. So terms that cancel. And they are actual holes in your graph. They're going to be an X and a Y. We're going to figure out what that actual point is. Looks like this one's like over 2 down 1, but that is what we're talking about in terms of a hole. Actually, I'll put that in here. Looks like it's 2, -1. Vertical asymptotes, they are usually represented by a dotted line. We've done these before. Vertical means going up and down. This one happens to be at -3, so your vertical asymptote here would be x equals -3. These are, again, values you can't have. So any vertical asymptote that you have, that is a part of your domain that you cannot have. So x cannot be -3. You can get ridiculously close to it in both directions from both sides, but -3 cannot be a value of your domain. Horizontal asymptote, same thing, only they're laying horizontally. They go through the y-axis, so this one would be y equals 1. X-intercepts happen where your x-intercepts is where your numerator equals 0. So you're looking for the places where your graph crosses the x-axis. This one looks pretty straightforward at 6. Y-intercepts are where you cross the y-axis. This one looks like it's at -2. So for x-intercepts, your y is essentially 0, and for y-intercepts, your x is 0. So they kind of are each other's opposites. Domain, again, are your x values, ranges your y values. So domain's going to be, for our graphs, it's going to be everything except. And then we're going to have to lay out the exemptions. So all real numbers except x cannot be. Must have both of these parts. We're essentially saying it's everything except for there's going to be a couple that I need to exclude. Need to have the x does not equal because you're saying it's the domain values, the x values. So for sure, any holes, that can't be a part of our domain. That is something we literally are skipping over, so we cannot use that. And we want the x value of that, so cannot be a 2. If we have a vertical asymptote, which we do, we also can't be that number, so -3 would be another part of our exclusion. Range, kind of the same idea. We're going to be all real numbers except, and then we're going to talk about some things that we cannot be. So any horizontal asymptotes, so this one happens at +1. And then our y value to our hole. So this -1, it not only can your graph not have 2, which is right there, it also cannot have -1. So wherever that hole is, it can't have the x value or the y value. So that's kind of the characteristics of a rational graph. We're going to do a couple of them. Make sure that you're using the steps because they kind of on the card because they kind of lead you right through how to do each one of these. So first thing you are supposed to do, step number 1 says you're supposed to factor and cancel. These guys don't factor. There's no squared. There's nothing in common to take out. So this is just what we're left with. So there aren't any holes. Vertical asymptotes are where the denominator equals 0. So I'm going to take x plus 1 equal to 0. I get x is -1. So my vertical asymptote is at -1. Horizontal asymptotes, you have to look at where the highest power of x is. In our case, both of these are an x to the first, so they match. So then you look at their coefficients, which happens to be 2/1. So your horizontal asymptote is 2. You cannot have a horizontal and a slant. So we had a horizontal, so we don't have a slant yet. We'll do those in a couple days. X-intercept you find by letting your numerator equal 0. So I'm going to take 2x plus 1 equal to 0. I'm going to subtract the 1, divide by 2, so I get x equals -1/2. That is my x-intercept, and that is a point, so we can put that in with a 0. My y-intercept is what happens if I put zeros in for all the x's. So 2 times 0 plus 1 and 0 plus 1. So 2 times 0 is 0, plus 1 is 1. 0 plus 1 is 1, so it looks like my y-intercept is at 1. So I'm going to put those things together and hopefully create our graph. We've got a vertical asymptote at -1, so that gets a dotted line. We've got a horizontal at 2, that gets another dotted line. We've got an x-intercept at -0.50, so right there. And we've got a y-intercept of 0, 1, so that goes right there. Our graphs, these rational functions, kind of usually have these two, for the most part, have two, sometimes have three. Kind of, I don't know, LJ-shaped type things, almost like an exponential or a logarithmic graph. And so I know that all I really need to do is connect these two and attempt to get close to the asymptote, and it's just going to kind of hover right next to it. Same here, can't cross the asymptote, so we're just going to get close. So we've definitely got half of our graph going. We need to find the other half. Vertical line test tells us it can't be up here. If we had something up here, we would hit the function twice and then it wouldn't be a function. So it's definitely got to be over on this side somewhere where I have space and I have nothing going on. So the last step on your card says we might have to do a test point. What that means is you're just going to make like a mini XY chart. We only need one value. We just need something on this side of the asymptote. So I'm just going to pick -2. Sorry, those negatives didn't copy very well. Those are all negatives. So I'm going to pick -2, and I'm literally just going to plug it in. So right here, 2 times -2 plus 1, and then -2 plus 1. So I've got -4 plus 1 is -3. On the bottom, I've got -2 plus 1, which is -1. So plus plus, I got a 3. So -2, 3. And that's enough to tell me that, oops, I did touch that asymptote. Didn't mean to. That's enough to tell me that my function looks like that. Can't cross this asymptote, have to get close in both directions. And there's my first rational function. We're going to do the domain and range for this function. So domain is all real numbers except x cannot be. We're looking for holes. We didn't have any, or VAs, so -1 has to be excluded. Range is going to be all real numbers except y cannot be any holes. We didn't have any. And then HAs, so we have one at 2. First step on your card says that we're going to factor and cancel. This time we're going to try it because this is a squared. Chances are x plus 3 is probably one of the factors. So we'll get this factored, and we've got x minus 4 and x plus 3. So go ahead and cancel. We end up with 1 over x minus 4. If you do factor and cancel, you cannot go back and look at this one anymore. You just have to focus on this. So since we factored and canceled, this is all we can look at to do the rest of the problems. What we canceled was an x plus 3. So that hole happens at -3. And then we're going to plug that in order to find our y. So plugging in -3 right there equals -1/7. So that's my hole. Happens at -3 and -1/7. VAs happen when the denominator is set equal to 0. So x minus 4 equals, oops, I did the equal sign already. So x minus 4 equals 0. Dang it, I almost did it again. Add the 4 over and you have a vertical asymptote at 4. Horizontal asymptote, highest power this time is in the bottom, and your card says when that happens you have an horizontal asymptote of 0. You can't have an HA and an SA, so no SA. X-intercept says that we have to set the numerator equal to 0. That would mean 1 is equal to 0. That's not a true statement, so you don't have any x-intercepts. You can't have 1 equals 0. That's not true. Y-intercept, you just put a 0 in for all the x's, so 0 minus 4. I've got 1 over -4. That I can graph. So let's put it all together. I've got a vertical asymptote at 4. I've got a horizontal at 0. Oops, missed that. I've got a y-intercept at 0 and then -1/4, so tiny. And that's really all I need for this half because I'm just going to try and get close to an asymptote, and I'm forced to go that way. And this one's just going to get close to the asymptote. So we need to check a test point over here. I can't put anything up here. It's got to be on the other side of the vertical asymptote. I'm just going to choose 5. So plugging a 5 in, I'd have 1 over 5 minus 4, which would be 1. So going over to 5, up to 1, and that's enough to tell me that my graph has to be looking like that. Domain's going to be all real numbers except x cannot be holes. We had one, so -3. And VAs, we had one of those as well, so 4. The range is going to be all real numbers except holes. We had one, -1/7. And HA's, we had one that was at 0. So the only thing we're missing here is to put the hole on this graph. And shame on me that I'm using pen. Hopefully you're using pencil. But at -3, right here, you need to literally just erase that and then put a circle there. I'll just put a circle there, even though I know my line's going through there, because I used pen, and I shouldn't use pen. So erase that so it looks like an actual hole. There you go. There's your first day of graphing rational functions.